All right, so for this game, we have what is effectively an in and out game, right? We have a bunch of stations here that need to be, some of which need to be closed, some of which will stay open, but really that's all we care about in this game. Which ones are closed, which ones are open. So we can set it up accordingly, except we can use, because the game itself keeps on referring to certain stations being open and closed, rather than the labels of in and out, we can just use those specific labels. Some of them will be open, some of them will be closed. Now, the elements themselves happen to be L, M, N, and we have P, Q, and R. I guess a minor point that's worth making is they do tell us that they're going to have to close at least one station, so we can put up a space there, but otherwise nothing beyond that in terms of the basic setup. So the rules themselves. So the first rule tells us that N and R cannot both close. So I guess we can say something like N and R, they cannot both be closed. I guess we'll just use C. They cannot be both on the closed side, which means we can take a minor step here rather. If N and R can't both be closed, we can say that at least one of N or R will have to stay open. Now, it's worth noting that they could both be open, right? This rule does not say that they cannot both be open, it just says they can't both be closed, but it does necessarily mean that at least one of N or R will have to be open. Next, the second rule says that if N is open, then L also must be open as well. So if N is open, then L will also have to be open. Contrapositive, of course, says that then if L is closed, and it's worth noting, we only really have two options, open or closed here, which means if L was not open, then naturally it would be closed. So we can say that if L is closed, then N would also have to be closed as well. Now, it's actually kind of worth recognizing that these two rules, they kind of could be interplayed into each other, right? Because what we have here, that first rule, that N and R cannot both be closed, I mean, really we can turn that into a conditional statement that we could then feed it into this. Because another way of saying that N and R cannot both be closed is to say that if one of them is closed, well, what's going to have to happen? The other one is going to have to be open. And we could have connected that rule into this one, which means that's not a bad idea to kind of do that. Instead of using this kind of anti-block, we can say, you know what? If N is closed, then what will have to happen is that R will be open. And alternatively, if R is closed, then what will have to happen is that N will be open, which is just another way of saying the exact same thing. But this way, we can chain these rules together. In fact, you'll notice the next rule is now also conditional, right? Because it tells us that if R is open, then M also must be open. So we can link this in. If R is open, then M will also be open. Contrapositive there then dictates that if M is closed, then R will also be closed. Lastly, we're told that L and R cannot both stay open. And the thing is, we already have L and R on the board here, so we can turn this into a conditional statement so we can latch it onto all of this. Basically, when we say that L and R cannot both be open, that means that if one of them is open, then the other one will have to close. Now, this creates a bit of a weird connection, but essentially we can say that if, for example, L happens to be open, then it'll lead to R being closed. Likewise, if R happens to be open, then it'll lead to L being closed. You have a bit of a backwards relationship here, but that's really all it is. Now we have a backwards relationship to some degree. Next, in fact, actually, wait a minute. When it comes to L and R, we can say that if one of them being open pushes the other guy to close, that effectively means that they cannot both stay open. So at least one of them will have to close, which means we can say that we can reserve another placeholder to say that one of L or R must close. Now, again, it's worth noting that they could potentially both close, right? Because if one of them closes, it doesn't necessarily push the other one. Actually, I guess that isn't really true in this particular game, because it's worth noting that in this scenario, if one of them closes, if L closes, it actually does push the other guy to open. So it actually does end up being true that they cannot both stay closed either. That said, though, we wouldn't be able to put a placeholder on, not a unique placeholder on the open side, just because we already have an R in play here. That said, though, because we have all of these connections, we actually could extract an extra placeholder that might come into use later on. Because you'll notice that, for example, if M closes, then all of these things will happen, which eventually leads to L being open, right? So if M is closed, then we know that L will have to be open. So we could actually take one more step and say that M and L certainly cannot both stay closed. That means that between M and L, at least one of them will have to be open. For the record, if you're having a bit of a hard time with where the placeholders go or whatever, this is basically part of the in and out lesson, so you might want to go back and brush up on that. These kinds of mechanics, they should become a little bit more second nature by the time that you get to the test. So if you're having a hard time with it, it's not a bad idea to kind of refresh that lesson. Anyways, let's take a look at the questions themselves. So the first question here is our standard exclusion question, which says, which of the following could be a complete list of the stations that could stay open? Well, for these, as usual, we go by the rules. The first rule told us that N and R cannot both close. Now, worth noting that another way of saying that N and R cannot both close is to say that at least one of N and R, which is what we did here, will have to be open. So going through the answer choices, that would disqualify answer choice A. B looks good, C looks good, D looks good, and E looks good. They all have one of N or R, so that's viable. Next, if N is open, then L also has to be open. So let's take a look. Do we have any cases where N is open? And yes, it looks like answer choice C has N open, but it does not have L open as well. So we can disqualify C for violating that. Next, we're told if R stays open, then M has to be open. Again, we can look for any violations of that. So answer choice B, you'll notice, has R open, but there's no M there, so we can get rid of answer choice B. Answer choice D does have R, but it also has M, so that's still fine, and same thing with E. Lastly, we have L and R cannot both stay open, and E violates that since L and R both are open there. So the best answer to question number 12 then is answer choice D. I guess for good practice, we can also plug that into our board. So we have M, Q, and R is one scenario where the three of them are open, and then the other three elements, I guess we're left with L, P, and N. Those will be closed. So this is just one possibility. Next, let's take a look at our local questions. So question number 13 says, if exactly 5 stations stay open. Now that's pretty restrictive. If we have to have exactly 5 stations be open, I mean, we only have 6 elements to play with, which means that right now we're going to have exactly 1 station be closed, which means that if that's the case, we actually kind of already know who that is. We already know that one of L or R has to be the station that ends up staying open. So, closed, which means right now everybody else is going to have to go on the inside, right? So we're going to have M, we're going to have N, we're going to have Q, we're going to have P, and effectively the other of L or R. The thing is, though, we might be able to do more damage because one of these 4 guys, M, N, Q, and P, might actually still trigger something in the game, right? So we can say, well, if M is open, nothing really happens. If N is open, oh, there it is. If N is open, then what's supposed to happen? Then L is supposed to be open, which means we can resolve this. This is not going to be L or R. It's just going to be L, and this is just going to be R. So the question now asks, which of the following must close? Well, we have that. That would be R. Best answer to question number 13 is E. Next, number 14 is global. We'll come back to that one in just a moment. Let's take a look at number 15. So number 15 says, if L stays open, then any of the following could be true except. Well, let's see what we can do with that information. So if L stays open, I guess the question becomes, what does that tell us? What does that effectively mean for us? Well, the thing is, if L stays open, it triggers all of these guys to kind of kick in. Well, actually, it doesn't trigger the M, but if L stays open, it does lead to, specifically, R being closed, and in turn, N staying open. Now, we don't actually know anything else, right? Because we're not triggering M, and then anybody else is not really touched. This is as far as we can take it. The question itself asks, which of the following basically cannot be true? Answer choice A, M closes. Well, we don't know what happens to M, so that maybe could happen. B, N closes. Well, no, we definitely know that right now N stays open, which means this cannot be true. The best answer to question number 15 is B. Next, number 16. if exactly 2 of the stations stay open, so again, that's pretty restrictive. If exactly 2 stations are open, that means that we're going to have exactly 4 stations close. Now, the thing is, we actually have these placeholders in play, right? We know that on the open side, we're going to have one of N or R and one of M or L, which kind of reserves both of the open slots. And that's pretty good, because now that means that everybody else, which I guess that would be P and Q, is going to have to close alongside the other of one of N or R and the other of L or M. It's worth noting, though, these placeholders, they kind of take up all 4 of the elements that actually have rules associated with them, which means we can't really go much further. Fortunately, though, we don't need to. The question asks, which of the following must close? And we definitely know that both P and Q are going to close. So the best answer to question number 16 is D, which is Q. Next, I guess number 17 is a modifier. We'll come back to that one in just a second. Let's take a look at number 14. The question asks, the stations that close could include both of what? So what are 2 stations that could both close? Well, let's take a look. Answer choice A, could L and M both close? Well, it's worth noting, if L closes, then M gets forced to open, which means no, they cannot both close. Answer choice A is out. Next, B, L and R, same thing. You'll notice that if L closes, then R will have to open, so they cannot both close. C rather, could M and N both close? No, similar issue. If M closes, then N would have to open, so they cannot both close. Next, D, M and R. Well, if M closes, then R closes. That actually looks pretty good. It looks like M and R seemingly could both close. Answer choice D then is viable. Just in case, let's take a look at E. Could N and R both close? Well, no. If R closes, then that forces N to open, and that gets rid of answer choice E. So the best answer to question number 14 is D. Lastly, our modifier question. So which of the following, if it were to replace the rule that says that if R is open, then M is open, would have the same impact on the game? So effectively, we're trying to replace this rule over here, which is the same as the contraposed version over here. Basically, we're looking for something that would have the same effect. And just to kind of recap, remember, when you're replacing a rule, there are 2 parameters you're looking for. You're looking for something that would have the exact same impact on the game, which means it guarantees that this restriction will be maintained, that anytime R is open, then M will be as well. And also, you're looking for something that always had to be true. Let's see what we can do. Answer choice A. If L closes, then M must open. Well, on the must be true territory, this is actually true, right? Because originally, if L closed, then M would have had to be open. So that certainly always had to be true. The other question is, would that have guaranteed that any time that R is open, then M would have been open? Well, the thing is, anytime R was open originally, what it would have led to is that L would have been closed. And according to this rule, if L closes, well, then M would have had to be open, which means indirectly that would have meant that any time R would have been open, M would have been open as well, which means answer choice A is actually a pretty viable answer choice. We're going to hold on to that one. For the rest of the answers, if L closes, then R must open. Now that also always had to be true. The thing is, though, you'll notice that this has no impact on M, which means that this can't possibly guarantee that when R is open, then M is open, because this doesn't do anything at all about M. So answer choice B gets disqualified. Answer choice C, if R closes, then L must open. This is also true. If R closed, then L would have had to open. This is something that always had to be true. The problem is this has no impact on M, so we can disqualify answer choice C now. In fact, it's actually worth noting B and C are logically identical answer choices. They're actually contrapositives of each other, which means they can't both be right, so they both must be wrong. Answer choice D, if L is open, then M must close. It's worth noting that never had to be true. When L was open, this never actually led to M being closed. So because this never had to be true, answer choice D gets disqualified. And lastly, if M is open, then N must close. It's worth noting this also never had to be true. When M was open, there were no consequences to that originally, which means that if this never had to be true, then this wouldn't be a viable answer choice. The best answer to question number 17 then is A.